Well, good morning. Let's get started. Thank you everyone for attending the May Town Hall through IGSHPA. Really appreciate everyone participating today, and I cannot wait to hear the presentation. But just a few updates and information through IGSHPA. So news and updates, future town halls, and any dig deeper registration, you can find them on the IGSHPA website and just click on events, and each one of those will have a registration tab for you. A few new things, we do have abstract submissions for any future events on our events page, and then our new business directory, which is amazing. If you haven't had a chance to check that out, please go to the IGSHPA website and click on business directory. You'll be able to sort through businesses, look for certified professionals. It's amazing the amount of information that we have available. So if you have any questions, feel free to send an email to info@igshpa.org, and we'd be happy to help in any way we can. Just as a reminder, we do have our conference coming up in December. Our 2022 annual conference is also, again, partnering with National Groundwater, which should be wonderful in Las Vegas this year. Again, you'll find more information at our website, igshpa.org, and space is going fast for exhibitors, sponsorships. So check it out. If you have any questions, again, send us an email. We'll be happy to help. We do want to thank our current conference sponsors. Platinum sponsor, Climate Master, gold sponsor, Grundfos, silver sponsor, Enertech, but we do have some sponsorships still available. Diamond is still available. We still have 2 gold, 3 silver, and 5 bronze spots available. If you have questions about sponsorships or would like more information, again, feel free to reach out to info@igshpa.org. We are still looking for speakers. Abstracts are due by May 31st, but if you have any questions about topics or any information about the conference, feel free to reach out and we'll be happy to answer any of your questions. CEUs and renewals. We are still accepting renewals all the time, but we are no longer waiving CEU requirements for those renewals. This event, the town halls, dig deepers, and our annual conference all qualify for CEUs. And if you would like CEUs today, please send a chat message within Zoom and we'll be happy to include you in that information. Just a little bit of housekeeping for today's presentation. If you could keep yourself muted at all times, that would be wonderful. We are recording the session and it can be viewed on the IGSHPA YouTube page later. And then I, Courtney, will moderate today and I will field any of the questions for the speaker. If you have questions, just feel free to type them in the chat function and we'll have question and answer period at the end of the presentation. So now that we've got through all that fun housekeeping stuff, I get the pleasure of welcoming our speaker. Jeff Hammond is the Executive Director for IGSHPA since October. He joined IGSHPA with 35 years experience in the geothermal heat pump industry. Jeff is a member of ASHRAE, AEE, ASAE, and is chair for the next edition of the ANSI CSA IGSHPA C448 ground source heat pump standard. With all of that wonderful information, Jeff, take it away.
Thank you, Courtney, and thanks everyone for joining us this morning. I'm excited to talk about geothermal. As you can imagine, I get accused of being a geo junkie. So the topic here is how geothermal compares to conventional. I don't think there's any comparison, but in all fairness, we probably should talk about how it compares so that as we see more and more geothermal installations and we have more interest, we can talk about it a little bit more. This is part of a 2-part series. So I'll be doing the technical portion of it today, talking about the differences between geothermal and conventional gas furnaces, air source heat pumps, as far as where we might have some opportunity for savings and ease of installation. And part 2 is Rob Dirksen of Michigan Energy Services. He'll be tying those components together from a costing standpoint and a sales tip discussion. So between the 2 presentations, we'll be able to talk about differences, not just in operating costs, which is what we focused on all these years, but there's some advantages for installation and a lot of other advantages that sometimes we don't concentrate on. I'm going to be tying in a report that just got released. I just saw it last week. It's from the New Buildings Institute and Natural Defense Council. Came out in April that provides some information on decarbonization. But what's great about it is it ties in installation costs that we really should consider when we're looking at geothermal. It's concentrating on electric systems. So the goals of this presentation, we need to consider how to discuss geothermal versus other HVAC technologies, and we're really making fair comparisons. You know, it's kind of an unknown for a lot of contractors, and I certainly understand that. Sometimes there's some additional cost in there because we haven't looked at all the components, and that's what we plan to do here today is look at how they differ in installation and how that affects labor and costing and so forth. But there might be some avoided costs in new construction especially, and that's if we look at an all-electric solution, which is becoming a trend in a lot of areas. There could be some hidden costs with regard to, say, the electrical panel, things like that we'll look at. We can also take a look at complementary technologies. You know, for example, maybe we would go with a smaller solar array if we chose geothermal over an air source heat pump. So those are some things that we can take advantage of. And hopefully this will segue into next month's town hall in June. And Rob will tie in the financial part of it and the sales discussion with how we're comparing. All right, so the new report I mentioned, this is just came out in April. It's the cost study of building decarbonization code. And I won't go through a lot of it because we have a limited amount of time, but it certainly has some good takeaways that we should apply in how we're talking about geothermal versus other technologies. It did concentrate on a slice of the US. You can see here in zone 5A, it's this green highlighted area from Nebraska out through the east coast of the US. And so it's focusing on a heating dominated climate. Not that you don't need heating in Minnesota, but this is an area that they focused on as an example. It could be spread to other parts of North America as well, but this just happened to be where they were doing the study. They compared in this report their baseline, which is the minimum efficiency code equipment, furnace, air conditioner, gas water heater, gas range. Looked at a mixed fuel installation, basically just an upgrade of the furnace, a 96% condensing furnace, and then all electric system. Unfortunately, it did not compare geothermal, but with the data that's provided, we can really build on this report because the only difference really between the air source heat pump and geothermal is the ground loop. So we have some good information to build on, and especially in new construction, it provides some pretty amazing information. This is one of the main takeaways that is quite interesting. They looked at incremental first cost. And if you look at this chart, it takes a little while to digest, but the way it's set up is this first bar, it's actually, these are negative numbers, versus the minimum efficiency code requirements, the gas furnace, gas water heater, and gas range. They used RS means as their benchmarking for installation costs. And on an all electric new home, their study in zone 5A showed that it's about between $2.15 to $2.35 per square foot less cost for an all electric home versus their base example, which is the gas furnace, water heater, and range. If they wanted to look at electric vehicle charging infrastructure, they would need to add in 3 cents per square foot. If they only did that, it would be 3 cents per square foot. If they combine then the all electric home and the EV charging infrastructure, it's still between $2.12 and $2.32 per square foot less cost than the base example. So in dollars, that is between $7,500 and $8,200 less cost to build this new home. Imagine what we could do with that money. It would go a long ways towards a ground loop. So this is something that I haven't seen before in new construction. I think we all assume that the minimum efficiency base system, furnace, air conditioner, water heater, range, is about the same price, but it's really not. When you start to look at the cost of piping and venting and so forth, there can be a real advantage that we're just not taking advantage of. When they compared the mixed fuel scenario, this is just simply that higher efficiency gas furnace. It added, which we would expect, 28 to 48 cents per square foot for that high efficiency furnace. If they added in electric vehicle charging infrastructure, then they're at 32 to 52 cents per square foot adder. So really there's quite an advantage. Even though this is an air source heat pump, if we just look at it from an all electric home standpoint, we already have savings before we even start talking about the rest of the system. So quite interesting and very timely that it came out in April. The results that they show in this report, and we would certainly be happy to share that report with you. Just send us a message or send a chat. We'll be happy to do that. With the air source heat pump, they're showing a total energy reduction or energy consumption reduction of 34%. Imagine if we had Geo, and especially now with gas prices, which I have a slide coming up because we haven't really looked at gas prices in a long time. We've assumed that gas is cheap. Yeah, not so much anymore. So we have to look at that. The all electric scenario you saw from the previous chart, it's less expensive to build based upon their study in that zone 5A using RS means data. And this is interesting, the reduction in carbon emissions. Again, an air source heat pump. So we have an opportunity with Geo to have even more reduction, 126.2 metric tons. So it's a pretty interesting study. I was fascinated by it, but I'm kind of a data junkie, so I like that stuff. This chart I pulled last Friday to see what gas prices are doing. I know it's a little hard to see. There's a lot of information here, but the very last number here in green, it was the gas price on the commodities market last Friday. So this is over a pretty large span, 21 years. If you look at 2022, you can see where it started here. It's been rising since the beginning of the year to the point where it is now. And by moving the cursor over this chart in Yahoo Finance, you can kind of track how the gas prices have been. To look at a cost that's the same as where we are today, we'd have to go clear back to 2008 to see where we were with gas prices. Now that's not adjusted for inflation. So if we adjust this for inflation, now we're actually back into 2005. We're tied for the highest in the past 21 years. So this is a story that does need to be brought to everyone's attention. We've said gas is at a 20-year low, and yeah, it probably was back in this era here, but we're actually now tied for the past 20 years for natural gas prices. So this is something that does have some impact, assuming that inflation is going to at least continue for the short term, maybe the long term, depending upon what happens. It's probably not going to go down. So as we start to talk to customers, this may be something to consider. So let's talk about the technical details now. If we look at geothermal versus traditional HVAC systems, and I'll concentrate on gas furnaces and central air conditioning, and as well as air source heat pumps. So what are we comparing? Well, first off, we have to look at this statement, Geo is expensive. That's something that we've battled. It depends on what you call expensive. Is a nicer vehicle too expensive than a lower cost vehicle? So there's some things we have to address there, but we'll compare the components and take a look at where we might have some interesting discussion. As I mentioned, Rob Dirkson's going to talk about the costing portion of this in the June town hall, as well as sales. So I started with an example in the Midwestern part of the US, new construction, and I picked some numbers that are fairly typical. 61,000 BTUs per hour heat loss at 0 degrees outside and 70 inside, 39 total heat gain with 32 sensible heat gain at 95 outside and 75 inside. So my comparisons are based upon this typical installation. I started with a gas furnace, gas water heater, central air conditioner, gas range, and this is just a drawing that's actually out of the IGSHPA residential light commercial manual. I added the water heater that wasn't in there. And this next slide shows some of the components that we don't often talk about, but we should, because there's costs associated with it. So if we were to look at a geothermal installation, I know this seems pretty obvious, but until you start putting pen to paper, you don't necessarily notice some of this stuff. We obviously need a gas line for a gas furnace and for the water heater. There's costs associated with that. In this example, we have a condensing gas furnace, so we need to bring in fresh air from outside, and we need an exhaust here. So we have two pipes, probably wall penetrations, most likely. The water heater flue, if it's new construction, it may be a roof penetration. If it's an existing construction, maybe they've tapped into a chimney or something like that. So those are certainly costs and materials, labor as well, that we need to consider. If we go with a packaged geothermal unit, we don't need this line set. There's cost, wall penetration that needs to be considered. We still need a condensate drain for cooling mode, but we don't need two. I have one here for the gas furnace because it's a condensing gas furnace, and I have a second one for the evaporator coil. So when we start to look at the components, what do we actually take away when we go with geothermal? It's awfully nice not to have all that gas piping and refrigerant line piping and venting. There's a cost associated with that, both from a component standpoint and from a labor standpoint. We take a look at an air source heat pump. This kind of cartoonish looking graphic gives you an idea of the comparisons here. It's actually a little simpler than that gas furnace because we don't have gas lines, we don't have venting. And really the only difference here is, since we're bringing these components inside, we don't need a line set. So we even have some savings compared to air source heat pump. Now we have to add in some additional components with geothermal, but from a equipment standpoint, we are eliminating this line set, which is component cost and labor cost, wall penetration that we wouldn't need. When we look at geothermal, these components here, some of them would be additions, depending upon how the installation goes. If the contractor subs out the loop contractor may handle just the outside portion, or in some cases may handle piping all the way to the heat pump. If that loop contractor handles piping all the way to the heat pump, then really it's less components and less labor than either the gas furnace installation or the air source heat pump installation. You still have duct work, you still have to set the unit, but really it's simpler. And I don't think we think about that much. We're kind of used to talking about all the adders for geothermal, but in some cases we actually have less to have to deal with. So that's kind of important from that respect. There are always hidden costs that we have to consider, and these sometimes are not obvious. But if we're comparing the air source heat pump in particular, we could certainly affect the amount, the components, the electrical system, labor, wiring, a lot of costs there that aren't always discussed. I like these charts. They kind of show what happens over the course of the year in the heating mode. And this one is an air source heat pump. I have a geothermal heat pump coming up that will compare. I pulled this curve out of the manufacturer's data. So this is published data. You can find it on the website. This happens to be a 4-ton, 2-stage air source heat pump. It's 17 SEER cooling efficiency and 9.5 HSPF heating efficiency. And you can see the capacity as the outside temperature drops, goes down, which we would expect. This line right here is the building heat loss. As I mentioned earlier, this example I used was 61,000 BTUs per hour heating, heat loss at 0 degrees outside Fahrenheit. So when you compare what the building needs to what the heat pump can provide, that's how we come up with this balance point. At 31 degrees outside, the heat pump capacity can still heat the home, but when it's below 31 degrees, then all of a sudden we need this red area, we need some backup heat. And at design conditions, in order to heat that house, even though it's only 2.5% of the time of the year, we have to bring in backup heat in order to satisfy the thermostat. So I took the heat pump capacity and subtracted that from the total heat loss, and that's where this triangle comes in right here, the backup electric heat. It's about 45,000 BTUs per hour. If we convert that to kilowatts, we need 13.2 kilowatts to heat the house at 0. Now, of course, we don't need as much when it's warmer outside, but we have to design for our outside temperature that is the design point for that particular location. So I mention this because this affects cost, and this could be some of the hidden costs with electrical requirements, wiring, labor, and so forth. As a side note, I also looked at efficiencies, because this gets discussed quite a bit, but we don't really dig into what's actually happening. Again, this is right out of the manufacturer's data. So it's interesting information to look at, but when you start to put it in an actual application, it's quite interesting. This is the COP, coefficient of performance. So this line right here in red tells us what the efficiency of that heat pump is, and it's just the heat pump, does not include electric heat, from 67 degrees outside Fahrenheit down to about -3. And so when we look at this particular example, the 61,000 heat loss, we have our balance point at 31 degrees. This purple line is the combined COP. So this is the efficiency of the heat pump with electric heat. Once we get below 31 degrees, we have to start bringing on some degree of electric heat, all the way down to design conditions. Good news is that all the way down to 0 degrees, we still have an efficiency better than 1. So it's still better than having just electric heat running. Not a lot. By the time we get below -3, we probably want to shut this heat pump off, because we're just using the compressor and not getting a lot of gain. But this is something that doesn't get looked at often. We talk about, HSPFs, we talk about high efficiency, and heat pumps are great. They're very reliable now. But when we actually look at capacities, we have to take a look at the combined efficiencies as well, because the lower capacities, we need to bring in some electric heat. So we're down to about 1.17, just as a reference. Now let's bring in the geothermal heat pump and see what that does to our electric requirements. I did use the same graph. Obviously, geothermal doesn't care about the outside temperature, but in order to use this graph, I correlated the entering water temperature with the outside air based upon what we would typically see. So this line right here is the geothermal heat pump heating capacity as it gets colder outside. Of course, when it gets colder outside, the heat pump runs longer, so the loop gets colder. So we do have a lower capacity as it gets colder outside, all the way down to this design temperature here. So that's still our heat loss, this line. This is the heat pump capacity. And our balance point now goes from 31 degrees with an air source heat pump down to 16 degrees. So you can see this triangle is significantly smaller, and only about 5.3 kW of backup heat needed with this two-stage unit. This is an Energy Star 24.9 EER unit, two-stage, 4-ton. So I try to compare apples to apples here as far as equipment components go. So the difference is 13 kW to 5 kW, really. Some variable speed geothermal heat pumps could even eliminate this. Likewise, there are some variable speed air source heat pumps, but we do have still some capacity degradation as the outdoor temperature gets a lot colder. In all fairness, since we looked at the COP for air source heat pumps, we should look at the COP for geothermal heat pumps with electric heat, because we show some electric heat here. At the balance point, we have a COP of 4.02. So for every unit of energy we're using, we're getting 4 units of heat out of that particular application. If we look at design conditions, this does include electric heat. So our combined COP when it's 0 degrees outside for this application is 2.91. So almost 3 COP with electric heat at the coldest day of the year. That was versus 1.17. So you can see here where there is quite a bit of difference. It would be like running that air source heat pump between 25 degrees outside and 50 degrees outside. It would run really well at those conditions, and a lot of air source heat pumps do operate in that range. But as we get colder, that's where the electric heat need is significantly less. So how does that tie to the technical portion, the components that we're talking about? Well, it has a big influence here on our backup heat selection, assuming that we're going to go with a 2-stage unit versus variable speed, which could affect this, obviously. We need 13.2 kW on the air source heat pump to meet the thermostat needs, okay? So that would be a 15 kW heater in all practical purposes, we probably couldn't buy a 13.2. I don't believe. Our full emergency heat, if we wanted to plan for failure, which, you know, you always have to ask yourself, does a gas furnace have full emergency backup? So, you know, that's kind of a judgment call there. You'd have to go with 20 kW if you wanted to have the full backup. If we did go with 15 on this air source heat pump, we would still be able to provide 59-degree temperature in the house, even at design conditions. What I've seen in the Midwest is most 410 air source heat pumps actually have a 20 kW heater. So I use that for my comparison. Really wouldn't have to have it, but it just depends on the comfort level with the contractor and the homeowner, in this case with a residential application. When we look at geothermal, here's where we can have some pretty big impact. And I have a slide coming up that shows wire size and breaker size, and even our electrical panel, which could be affected. If we wanted to, we could go with 5.3, but again, we're probably going to need to go to 10 kW. That's what would be the typical size that would be available from most manufacturers. Again, 20 kW if we wanted full emergency. That's not typical on geothermal. Where we see that a lot on air source, at least from my experience in the Midwestern part of the US, it's not typical to have full backup on geothermal. And that's a good thing, because if you plan for failure, then you're kind of jinxing yourself. You know, you're hopefully not going to need it. If you have a pump failure or something like that, I suppose it could be, you know, the unit could be offline. But even this 10 kW heater is going to keep that space above freezing. So you're not going to have pipes freeze and anything that's really traumatic if that heat pump's not running. So typically we would see a 10 kW heater on the geothermal application and 15 or 20 on air source. That has some pretty big impact on our electrical requirements. And in some cases, we might be pushing it a little bit. Depends on what other appliances are in that house. In most cases, our 10 kW heater is going to take a 50 amp breaker and number 6 wire. Okay, so that would be our geothermal unit. If we go with the 20 kW on the air source heat pump, take a look at this breaker requirement, 100 amps and number 3 wire. So we're adding quite a bit of cost. Copper is really expensive right now. I just did some wiring. It's certainly gone up significantly. But in this case, we might be in trouble with our electrical service with this 100 amp breaker, depending upon what else is on the service. As we start to look at electric vehicle charging requirements, you know, that's a load that could happen any time of day. So we have to plan for that breaker. A lot of cases, EV chargers are 30 amps, 40 amps, some are 50 amps. So we might be able to get by with 200 amp electrical service and an EV charger if we have the geothermal backup heat. Whereas we could potentially push our customer from a 200 amp service to a 400 amp service if we need that great big electric heat on the air source heat pump and we want an EV charger. So now we've got to consider the heat pump, the electric heat, the EV charger, the range, the dryer, you know, all the electrical loads, plug loads of the house. So this is something that we really should consider when we're comparing costs. Not only do we know that it's $7,500 cheaper to build the house with all electric versus gas, but now when we start to look at comparisons to an air source heat pump, we may have some cost here that could involve electrical upgrades, and certainly copper wiring is not getting any cheaper. So just something to keep in mind there. Infrastructure, this is something that doesn't get talked about a lot, but I think it will in the future. Where I live, it's crazy cheap to put in gas lines. Hopefully that's changing. In fact, the electric and gas utility is combined where I live, and they provide 400 foot of connection at no charge. Some states that's changing, and in some cases it's not going to be subsidized anymore. So that gas line to the house could possibly cost tens of thousands of dollars. That'd put in a lot of loop. So we need to take a look at those things. I wouldn't expect it to stay this way, even in an electric utility. This happens to be a gas and electric utility, where they provide this gas line at no charge. That's going to change, I would expect. There are some cases, I've seen this in the past, where a transformer upgrade might be required. So, is that going to be something the consumer pays for, or does the electric utility pay for that? It kind of depends on the area. But it might be that Geo, with its lower demand, is not going to require the upgrade. Air source heat pump might. There's some factors there we could look at. Variable speed compressors, for example, may bias the ability not to upgrade the transformer, even if we're looking at all electric and an EV charger and all of the appliances. So these are some considerations that that we probably should look at as we're comparing different technologies. Retrofits, of course, are important. That report we looked at earlier was on new construction, but suppose the customer wants a more efficient system. Well, if they go from an 80% furnace to a condensing gas furnace, are they going to be able to run that new venting? They've got to have outside intake. So they're going to have a way to get that outside air to the space. Even a concentric fitting might not always work in some cases, depending upon how it's vented. So an electric retrofit might make more sense than what it used to, especially with the prices of gas today. I touched on this a little bit. The 200 amp service might need to be upgraded to a 400 amp, but here's sort of the opposite situation. Suppose on a retrofit, they only have 100 amp service. Well, even geothermal might push them over the limit with that backup electric heater, or converting to an electric water heater, or what have you. So we might want to look at some dual fuel options. I have a slide coming up that shows some options there that aren't looked at very often. It's kind of unfortunate because it's really a nice way to go to provide geothermal and a ramp up potentially later on to all electric. And with some of the two-stage systems that are available, you may be able to upsize the equipment a little bit and still not be oversized for cooling. So that helps us with our balance point. On a dual fuel system, we won't be running that gas furnace as much for backup. We have some options for water heating. A lot of systems have these superheaters or hot water assist. With a preheat tank, we could make some hot water, keep that gas water heater offline. And some manufacturers have heat pump water heaters. There are also manufacturers who have water to air units that also make domestic hot water. So there's a lot of options out there as you start to look at the heat pump manufacturers, where we can look at the various product types and make it fit more nicely so that so we can save some cost on the system, and maybe our incremental costs are not quite as much as what we would expect. This would be a dual fuel conversion to geothermal. Just about all the manufacturers have an outdoor split like this, but it doesn't get used very often. If we were to look at this outdoor split installation, you can see nothing changed inside this mechanical room. We would have to update the A coil here, the cased coil, to an AHRI match, but for the most part, it's going to be roughly the same size, likely. So we don't have a lot of ductwork modification. We keep the same gas lines, the same venting, water heater if we like, especially if it's 100 amp service, we may not have a choice. But notice the difference here between that first installation I had on the screen with the gas and gas furnace central air conditioning system. We probably can even use the same refrigerant line piping. So the difference is this outdoor unit. And that outdoor unit then has typically a pump or a pump station, flow center inside. We connect to the ground loop right here, and we're using basically the same setup that we have, but we've converted that home to geothermal now. And because of the low balance point, if you remember that chart earlier on, we're not going to need a lot of backup heat, which means we keep this furnace off most of the time. So even though it's not fully electric, it is a step in the right direction, and it gives that customer the ability to use geothermal most of the time. If we decided to go with an indoor split, we could certainly connect to this water heater. We'd want a preheat tank so we could heat some water before it goes into the gas water heater, again, decreasing some of that gas use, which is going to be more important as we start to see gas prices continue to rise. So keep this in mind as an option for dual fuel conversions. It's a much better approach than an air source dual fuel. because of that balance point. If you remember, the air source system had a 31-degree balance point. Well, at that point, we're going to be doing a majority of our heating, depending upon the climate, with the furnace. We can't run the heat pump and the furnace at the same time. It's an either or situation. With Geo and our lower balance point, this furnace stays off in the example we had until 16 degrees outside. So the vast majority of it's done with geothermal. Just something to consider. So some of the conclusions, I tried to give us about 15 minutes or so for questions at the end of the presentation. So I'll wrap up with this conclusion in another slide. We should really look at potential installation savings. You know, we've always concentrated on operating costs, but operating costs obviously are an advantage. Carbon reduction is an advantage. We have some installation opportunities here. And, you know, that $7,500 from the report I mentioned is timely because an all-electric home, a new one to build, is going to be less cost than a mixed fuel home. We should consider that when we're looking at loop costs. So that takes a big dent out of that cost. And if the installer is using a subcontractor for the ground loop, the inside portion is actually less work. You know, depending upon how much inside piping is done, there's opportunity for labor savings and component cost savings there. We are going to see electrification driving consumers to look at heat pump technology. So why not take advantage of some inherently available savings here with geothermal? It could be electrical panel savings, could be component savings, not having the gas piping, not having the venting requirements, things like that. But we still have ways we can retrofit, like our outdoor split system. So that gives us some other options. Rob Dirksen, as I mentioned, from Michigan Energy Services, is going to tie what I just went through into sales comparisons as well as costing. So it'll be interesting to see in June how all this ties together. We know the savings from the report, but from a contractor's perspective, Rob can give us some examples of installations he's had experience with, you know, and they install furnaces and air conditioners and air source heat pumps. So it's a good perspective to see how that compares with geothermal. So at this point, we have plenty of time for questions. I think Courtney has been monitoring the chat window. If there's anything that we can answer, let me know.
Absolutely. That was a fantastic presentation. Honestly, some of those slides are some of the most compelling I've seen in a while. Even if we just talk about balance points, I mean, that's a pretty compelling story to tell. Or even that first slide talking about that cost per square foot comparison. I mean, it is an incredible amount of ground loop we could put in for that $7,500 savings. So we have a lot of comments in the chat today. So Kevin mentioned, never underestimate the power of expression. The real cost of gas is much higher when you consider environmental impacts. And then someone else mentioned, not to mention the line allowance costs, which your line allowance cost is fairly reasonable compared to a lot of areas in the country. Someone also mentioned design for heat loss plus defrost cycle doubles doubles the needed kW required. And then Bob asked, why doesn't the chart show extreme cooling needs? Doesn't capacity for air source fall as outdoor air temperatures grow to the extremes?
Yeah, that's a great question. And it does have an impact. You know, we're going to have lower demand, certainly with geothermal. I concentrated on heating because that seems to be where the conversations are going. There's a lot of discussion about, you know, infrastructure and grid impacts, things like that. So I concentrated on heating, but certainly in cooling, we have an impact. And if you look at the total picture, that report I mentioned earlier also had a light commercial installation as an example. Since we're focusing on residential for this presentation, I just stayed with heating, but that's a very good point.
Great. So Jerry asked, is there any good reason to consider just the two-stage air source or ground source systems when variable stage offers greater advantages?
Well, I think variable speed is becoming a lot more popular. It's really a trade-off. You know, right now in the geothermal industry, there are all those technologies available. single speed, two-stage, variable speed, and same with the air source. So eventually, I think everything will be variable speed, but it's a cost trade-off, and that's one of the topics that Rob's going to address in the June town hall as we look at some of these variable speed air source heat pumps, especially when they have vapor injection and they concentrate on trying to increase capacity at lower temperatures. You can end up in some cases, from my understanding, Rob can clarify this for us, the cost of that system may be the geothermal heat pump plus some of the loop. And then when you factor in the tax credit, there could be a similar cost and a lot less advantage. So I agree, variable speed's the way to go. It's a matter of really comparing apples to apples. I picked two-stage systems, but we could also look at 2 variable speed systems.
And that answers one of our other questions, was in either example, were we looking at single stage, 2-stage, or variable speed? But sounds like 2-stage units.
Yeah, sorry, I should have clarified that more.
No, absolutely. So Bob makes another point: dual fuel reduces gas consumption while not reducing required delivery infrastructure. Thus, long term, as consumption falls, delivery charges will increase dramatically.
Indeed. Yeah, if we had a choice of all electric, that definitely is the way to go. And yes, in new construction, I'm glad to see that report actually looks at incremental first cost, because why would we even add gas infrastructure if we don't need to?
Yeah, absolutely. So Greg mentioned this is great information. No doubt geothermal is a no-brainer when you're speaking to those of us who believe in geothermal. But in his experience, most heating contractors are order takers, not salespeople or analysts. Could we condense this into a capsule or a 2-page brochure that explains it to general owners? Maybe even a YouTube white paper?
I bet I know a marketing committee chair who is probably working on that as we speak. But,
I was 100% taking notes to be able to extrapolate some of this information to put it into something that we could share, whether it's still images or other information. But I would encourage any dealers or any OEMs on this call. I think this presentation and then the follow-up with Rob next month, I would share this to any dealers that you have as a way to just start the conversation comparing conventional versus geothermal and some of the differences.
I should clarify, Courtney is our marketing committee chair. Sorry for the inside joke there.
Yes, absolutely. So if anybody would like to help in the marketing committee, let me know. But Mike also asked, what are some good cost comparison programs to use?
Well, there are a lot of good ones out there, really. I think all of the heat pump manufacturers have cost comparison programs. My experience with them is they're pretty good. So I would work with your heat pump manufacturer, and it will allow you to put in the heat loss, heat gain that you've calculated, and then compare geothermal to furnaces, heat pumps, so forth.
Great. So then Kevin mentions GeoExchange also reduces water used in larger commercial buildings since they don't need cooling towers. So maybe another follow-up town hall that we could do would be applying this to commercial buildings and talking about some of the balance points we have that will be a little bit different on the commercial side, I would think, comparing these technologies. So good fodder for future town halls, or maybe an event at our upcoming conference would be a good conversation to have there. Then Pete mentions, isn't the loop really the fuel source? Wouldn't that make the comparisons much more understandable to the common purchaser of a unit?
It certainly is. I've never heard that before, Pete. Sorry, just joking. But yeah, and I think that, there was a point made earlier. We need to probably condense this information and make it more available. I could see where we may want to concentrate on the loop. I was concentrating on the mechanical portion here, but we really ought to have an offshoot here that talks about the loop, because it is a fuel source, especially when we have that $7,500 in savings. Would you want to put that $7,500 in a propane tank? I certainly wouldn't, but that's going to be an opportunity for education. So we need to talk about that. It's a fuel source. We either buy it now or we pay later, right, Pete?
Cliff mentions, this is good information, but probably better directed at architects and custom builders, and that the average homeowner is not going to follow a lot of this technical information.
Yes, that's true. And the audience here really is not homeowners. I think we need homeowner marketing material. Certainly, the marketing committee is working on that. We also have the advocacy committee that's working with our state and provincial geo associations. So as we provide more of this, as we talk about more of these details, and we are able to provide more information, we really need to customize that material. The content needs to be contractor specific or homeowner specific. So my opinion is we have a lot of discussions to have with contractors. Homeowners aren't going to care about this technical stuff, but if we can automatically save some labor in this really difficult labor market, or we can start to save some infrastructure costs, venting, electrical upgrades, things like that, the homeowner ultimately will care, indirectly anyway. But we need to educate contractors as a part of it. Unfortunately, a lot of times our audience, we're preaching to the choir. So if we can take some of this information and create content where we could start to talk about people outside of our inner circle, I think that's where some of this information can be used a little bit better. But yeah, I 100% agree. We have to have the appropriate materials for the appropriate audience.
And I would echo that. And I would say that anyone on the call today, if you are a member of a local home builders association or other more localized associations, one of the things that I found while doing some outreach for IGSHPA is that most home builders associations will not advertise events like this unless we as IGSHPA are specific members. However, if you're a member and would like other members to have this information, these town hall events, or even this YouTube recording that will be uploaded, please feel free to share it. Or if you think that this presentation would be of benefit to the home builders associations or any other local organizations, feel free to reach out to Jeff, myself, or info@igshpa.org, and we would be happy to facilitate doing any of these presentations for anyone at any time. So again, to Jeff's point, we are preaching a bit to the choir with everyone, but would love to be able to spread that good message out. It's just sometimes not as easy as I would have thought. So more questions. Dave Buss, even though variable speed is more expensive, it also saves money in operational costs. So it generally balances out the cost while providing better comfort.
Agreed. And we could certainly do a case for that. I think there's a lot to be said there. Maybe we eliminate that electric heat. We're kind of used to having electric heat as an industry for backup, but is it a necessary security blanket? I think you could argue that with variable speed, we could design that system so we didn't need any electric heat. And as Dave mentioned, that's going to save some cost. But then there are systems out there that also use variable speed technology and heat domestic hot water with it as well. So yeah, we could actually create quite a few different versions of this. I'd encourage anybody who is thinking about attending the conference in December to submit an abstract, because that's the type of information I think people need to know about. And we would love to have more speakers who can talk about real world type applications who have had experience with those type of systems for sure. We'd love to hear from you.
And I actually think that would be a good one, is specifically talking about installing systems without backup heat. I know as a ground loop installing contractor, we run into those systems. However, they don't explain to the homeowner, if you don't use strip heat, or if you turn it off and the system runs, you're going to run the loop field out of energy a lot faster if it was designed using that strip heat. So there is a lot of information. Maybe you'll even find that in our Certified Residential Designer course as we start to roll that out towards the end of the year about that information. So another follow-up question. Tom asks, do the heat pump manufacturer software include compare these hidden installation costs or only operating costs?
Well, that's a really good question, because they do, from my knowledge anyway, only show operating costs. And we've sort of been fixated on that as an industry. There are probably good ways to include some of these hidden costs. I know some of the software talks about CO2 reduction and planting trees and taking cars off the road, things like that, which is important. But I'm not aware of any of them that actually talk about the infrastructure costs, hidden costs, things like that. There's probably an opportunity for that, because that makes a difference. Now, on the other hand, in Rob's presentation next month, he might have some ideas of how he would do that as a contractor. Maybe that's something that's incorporated. I'm not sure.
Great. So we have a few other comments, just good information to present to electric utilities around the country. They are vested in how to best handle electrification of the utility grid. Couldn't agree more. So if you have questions or have electric utilities that would like this information, again, we'd be happy to share it. And we are starting as IGSHPA and GeoExchange to really engage with electric utilities across the country. So if you guys also like more information on that, feel free to reach out. Dan did share a cost comparison software to check out from IATMO in the comments. And then someone also agreed with variable speed, that they use variable speed in the UK and provide domestic hot water too without electric backup for perhaps 95 to 98% of their residential installs, but did preface that with they don't have quite the extremes of weather that we do here in the US. Bob also commented long-term cost savings are only compelling for those who have access to sufficient capital to install equipment. However, low and moderate income homeowners are driven by short-term cash flow impacts, not long-term gains. So just things that are starting, I would look at even some of the electric utilities that are starting to finance those, or there are lots of other options out there. Dave also says, Dunsky has done a study in Canada that found a geosystem is worth about 40,000 Canadian dollars to the utility, load balancing, et cetera. Why are they not encouraging geo?
Yeah, we could have a whole discussion on that, which I'd love to sometime. And that's a good argument not to subsidize those gas piping, the 400 foot that Ameren does, because of the benefit to the electricity. You know, why are we subsidizing gas lines? I think it's just a matter of getting the message out. The Dunsky report is great. Martin Limas did a really nice job in a previous town hall, and that's recorded on the IGSHPA website at IGSHPA.org. We just need to spread the word. But an excellent point. I mean, it really doesn't make a lot of sense to continue to look at fossil fuels. I'm biased, obviously, but if you look at the numbers, they speak for themselves.
I completely agree. And that Dunsky report is incredibly compelling. If you have not had a chance to look at the YouTube channel and take a look at Martin's presentation on Dunsky, it was incredible. And I do encourage everyone on the call today to take a look at that. And I would also say Boyd Lee did a presentation last year about the impact to his co-op, and that was incredibly compelling as well. So those two really are great, compelling stories to share with any of your electric utilities or co-ops in your area. But again, if you have any questions or would like help on how to reach out, IGSHPA and GeoExchange, we're great resources and are here to help in however we can. That was our last question. If anyone has anything else, now speak now or forever hold your peace. But I really want to thank Jeff for your time today. It was a fantastic presentation, and I hope everyone on the call will join us for Rob's presentation in June. If you have any other speaking topics or any other questions for IGSHPA, please feel free to reach out to IGSHPA@IGSHPA.org, and we'll see you at the next town hall. Thank you so much.
Thank you.
Thank you. Bye.
Have a good day.